आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Life on the earth is due to earth's magnetic field. It what we can say restricts the cosmic rays that are coming from the sun.
What if we told you the Himalayas aren't just mountains? They are detectives holding clues to Earth's magnetic past, hidden in every layer of rock. Today we have with us Dr. Mahesh Ramrao, Scientist B at the Wadia Institute of Himalayan Geology, who is going to tell us how the study of the past and present magnetic fields of the Earth is going to help us figure out what's going to happen in future.
My name is Dr. Mahesh Ramrao Kapawar. I work here as a Scientist B in Activity 7 Structure and Tectonics Group of Wadia Institute of Himalayan Geology, Dehradun, Uttarakhand. My research topics are paleomagnetism, rock magnetism and environmental magnetism. So what basically I study is about Earth's magnetic field. The present day Earth's magnetic field we are aware of, but what about the Earth's ancient magnetic field? Okay, so since it has experienced changes, variations since its inception, so that is a topic of very much concern to understand the paleogeographic reconstruction, paleogeography, like things. So this magnetic field is basically preserved in the rocks, sediments. So the study of this Earth's magnetic field from the ancient materials like rocks and sediments is comes under paleomagnetism. When we study about the magnetic properties like magnetic mineralogy, magnetic grain sizes, magnetic domain states, that field comes under the rock magnetism field. Then when we deal with the environmental materials like topsoils, like lichen materials, like plant materials, now they are considered as the polluted. Anthropogenic pollution activities are there. So to understand the anthropogenic pollution activities input to the environmental material in terms of magnetic properties, so this field comes under environmental magnetism. We know that there is a basic principle in the earth sciences, that is we call principle of uniformitarianism, that says that present is the key to the past. Okay, so that's why understanding the past changes in the earth's magnetic field, then compare it with the present day and to simulate, to prepare some models, simulations to understand, to means what we can say, to get some idea about what could be its future Earth's magnetic field. So this is the basic thing we study. And then as I said that we also study the environmental magnetism of environmental materials to understand the input of anthropogenic activities towards pollution. So this will directly comes means in the favor of societal impact. So my PhD study area was Rajmal Trap in Jharkhand and Sille Trap in Shillong Plateau. So that was basically to these are actually two dissected units of single parental output. So that is Kargil hotspot. They have erupted in the form of Rajmal trap and Sillet trap around 170 million annum. So to connect these two outputs by the paleomagnetic direction, paleopoles, I studied them. Then again I have contributed towards understanding the magnetic mineralogy of these two inputs. And then again these are basaltic rocks, so they have erupted from some fissure. So to understand what could be the lava flow direction, so I have carried out another study, that anisotropy of magnetic susceptibility. So this is about my PhD topic. So since I joined here in May 2022, I have initiated working on Indus molasses. Indus molasses is the sedimentary sequences that comes in the Ladakh Himalayan region. So to prepare the magnetostratigraphy, to understand the magnetic polarity of strata-wise magnetic polarity of Indus molasses, I have carried out this study. So that work is still going on. Then apart from that, I have contributed one research article that deals with the magnetic properties of Indus Molas sedimentary rocks. Okay, what was the sediment accumulation rate and what are the sources for those magnetic materials of that sediments. So I have commented on that. So, and recently I have carried out field work in Naga-Shuppan belt, again to understand the exhumation history of Naga-Shuppan belt, that falls in the northeastern region. So that has come up due to structural tectonic activities like Indian plates, what we can say, diversion with the Myanmar plate. So that has created some arc and brought up the Naga-Shuppan belt. To understand that exhumation history, I have taken this as an objective. Then currently means one project is funded by DST Serve, so that deals with the magnetostratigraphy study of Karakoram Tethyan sediments. So there also I will deal with the exhumation history, and again I will contribute towards the global geomagnetic polarity time scale by contributing a magnetostratigraphy for that particular age. And then my future topics means I wish to extend in the Shivaliks, means northeastern Shivalik that are sparsely studied in terms of magnetostratigraphy, and then again wish to study in the field of environmental magnetism by studying some topsoils of the region to understand the anthropogenic activities in the Himalayan region. We are means actually performing very well in this field of science. So, and there is too much scope again to work in this field, and we are actually publishing good number of articles in this field. So let's see, in the future we will contribute better again. Industries are not interested in understanding what was the position of Indian plate since millions of years, and so this currently have no implications with the industries, but we have environmental magnetism field. So their industries can take interest in understanding what their industry is contributing towards anthropogenic pollution. We have a principle of uniformitarianism that says that present is the key to the past. So unless we understand about the past of our Mother Earth, we won't be able to see our better future. So it's very necessary to understand the past of the Earth's we can say precisely about Earth's magnetic field, so that we will have a better future. Life on the Earth is due to Earth's magnetic field. It what we can say restricts the cosmic rays that are coming from the sun. So its strength usually varies with time. So to understanding its strength in past through ages till date, and what could be its strength in the future. So it's very important to study this field for the better life, and to mitigate the what we can say mitigate our efforts that what we can say that hampers the Earth's magnetic field.
Okay.
As I talked about the Earth's environmental magnetism, so there we deal with the environmental materials like topsoils and all. So when we are consuming too much of this what we can say fossil fuel, so it interacts with these materials, and in one way or other we are consuming that material, and that is incorporated with our human bodies, our internal system. So some diseases like pulmonary diseases that comes up because of that, and when these dust particles or soil particles, they are with the magnetic material, so that is very difficult, that is very what we can say dangerous for human health also. So we have to some way find option to mitigate the fossil fuel consumption that is directly affecting our environment and to our bodies. In my PhD, I have published 4 research articles. They are in good impact factor journals. One is Journal of Geodynamics, which was at that time having 2.8 impact factor. Then second article is in Journal of Asian Earth Sciences, which was having that time some 3 impact factor. Then one that deals with the Earth's magnetic field strength, so that was published in the Indian journal, that is Journal of Earth System Science. And another journal that deals with the lava flow direction of that gave rise to Rajmal trap and Sillet trap, that was published in the Physics of the Earth and Planetary Interiors, means housed in the Elsevier housed journal. So these 4 articles I have published during PhD. Apart from that, I have during PhD only I have initiated collaboration in the field of environmental magnetism with the Jadavpur University group, and from there I have contributed in 3 research articles. So that deals with the what we can say topsoil materials that are infected by the industrial areas in the specifically Bengal region. So I actually published 7 articles from during PhD, and 4 articles I have published since my joining here.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation, technical support is given by Soumya Mishra.